Please join me in welcoming Alistair Rogers.
Thanks very much for the invitation. My relatives have often asked me if I believe in climate change. And if they're unfortunate enough to ask that question before my first cup of coffee, they usually get a terse no. And what I want to do today is to just go over just what some of these facts of climate change are. And then I want to talk about the role that plants play in determining the rate of global change. A lot of people don't realize, but plants are subsidizing our use of fossil fuels. And I want to talk about that a little bit. And then I'm going to go on to talk about some of the work that we've been doing in the Arctic to try and reduce some of the uncertainty that there is in predicting what's going to happen in the future. Just as a way of a little bit more background, I'm a plant physiologist and I've been studying plants. Started off in my degree and went on to my Ph.D. and it was there that I kind of realized for the first time the connection that plants have to the climate. And hopefully you'll get a feel for that by the time I finish. I just want to talk a little bit about the greenhouse effect. The greenhouse effect is a good thing. It's why we can all live on this planet. Energy from the sun warms up the Earth, and then the Earth radiates infrared radiation, which then passes into the atmosphere. And in the atmosphere, about 1% of the atmosphere is made up of greenhouse gases, principally water. And those water and those CO2 molecules will absorb that infrared radiation that's coming off the Earth. And they'll then re-radiate that infrared radiation back down to the planet and out into space. And that's what makes our planet habitable. If we didn't have an atmosphere and we didn't have greenhouse gases, this planet would be on average about minus 18 degrees Celsius instead of the comfortable 15 Celsius that it is now. And if you think about some of the other planets, Venus, which is not closest to the sun, is actually by far the hottest planet in the atmosphere because it has this thick, dense atmosphere which heats it up. So the physics of greenhouse gases absorbing infrared radiation and then warming up planets like our own is undeniable. And the question then is, well, what happens when you start adding more greenhouse gases into the atmosphere? And the theory would say that if we add more greenhouse gases into the atmosphere, they'll absorb more heat and the planet will warm up some more. And that's indeed what's happening. We've been adding CO2 by burning fossil fuels since the beginning of the Industrial Revolution here in 1750. And this has been increasing steadily year after year. I think I just read in the paper this weekend that it's actually leveled off a little bit in 2014. This is the CO2 record going back 800,000 years. So just to put this into perspective, this is geological and evolutionary timescales. Human beings, Homo sapiens sapiens, started to evolve at around 200,000 years before present. And you can see this record. This record is collected by drilling cores into the ice, just like you'll see at the start of the movie. Jack Hall is heroically trying to save an ice core that he was drilling in the Antarctic. And he was capturing this ice core at about the 10,000 years ago record. So what he's learning in that movie is not something that we don't know already in spades. But this same technology that you see represented in the movie was used to collect these ice cores, pop the bubbles in the ice, and measure the CO2 concentration in them. And a bit like tree rings, you can work out the age of ice pack via the snowfall events, annual snowfall events. So from there, other scientists are able to get this very, very nice CO2 record going back over 800,000 years. And the fossil fuel emissions are about 10 gigatons. And here, the terrestrial carbon cycle is about 120 petagrams, or 120 gigatons. And it's roughly balanced. The heterotrophic and autotrophic respiration are roughly balanced with photosynthesis. And you'll see that I've put a little larger than 120 sign there, and I'll get into that in a second. You see on the y-axis there is the annual land flux of carbon, and then against the year for these different models. And where those lines are above zero, that means that the land's a sink for carbon, and where they're below, that means the land's a source for carbon. So where you're seeing the lines that are going below zero, that's showing us that the terrestrial carbon subsidy of our fossil fuel emissions is vanishing, and where you see it going above zero, we're seeing that it's increasing. So you can see there's a large disagreement amongst the models about what's going to happen in the future. And policymakers are really interested in this because they want to know You know, how big's the sea defense wall we're going to have to build around New York City? You know, these kind of questions, and they need information to make decisions. And unfortunately, the models aren't giving them the kind of information they need. So there's been an effort to invest in these models. So the Department of Energy's recently started funding these new experiments. They call them NGs, which stands for Next Generation Ecosystem Experiment. And what they're trying to do is they're trying to go into areas where there's great uncertainty about what's going to happen in those areas, where those areas might be climatically sensitive and where they have a global importance. And the areas that they've been going into, I can show you some of these here. So, for example, this is a plot of the red bars here show where people are on the ground making measurements. And then the blue and the black plots there show either the total area of forest or shrub or the total vegetative carbon. And where we're putting these projects, they're called NG Arctic and NG Tropics. So the tropics there, we're going in there because there's a huge flux of carbon in and out of the tropics, but there's almost no measurements there, and we don't understand it very well. So just to kind of conclude this science bit here, so plants are really important. They're subsidizing our use of fossil fuels, and they change the rate of climate change. The more CO2 plants can take up and sequester in the biome, the less rapid our impact of burning fossil fuels is on the atmosphere. And also that, you know, the models are doing a really bad job at representing plants, and we're trying to do that better. And I just said that a few moments ago about the models underestimating the capacity for CO2 uptake in the Arctic.
I heard a presentation by a woman who was presented as being a paleobiologist, who talked about that there were a number of periods in the Earth's history where there was a massive release of carbon dioxide into the atmosphere, resulting in a change in the acidity of the ocean. And she said about 90% of all species went extinct. In terms of your model, with the carbon dioxide, could it reach that kind of levels eventually?
So if I'm getting your question right, it's, you know, could climate change lead to mass extinction type events?
To the acidification of the oceans.
Yeah, I mean, so if you think about like the paleoecology or paleoclimatology, that's some of the data that people used to like hindcast what was going on in the past. So I showed that 800,000 year record of CO2 from ice cores, and you can go back 20 million years and you can look at the boron isotope ratio in the shells of plankton, and that can tell you that the different presence of those ratios of those boron isotopes is determined by the pH of the ocean, which is determined by the CO2 concentration. So you can go back in time and see these things. So theoretically, if you go forward in the future, you could have large-scale ocean acidification. And we should be able to pick that up, and there's evidence that we're starting to see those changes in pH now. This is not my area, I'm a plant physiologist, but you know, that's certainly possible.
You know what's going on with a planet, and I can't get a feel for what's happening. It just bothers me. I think a lot of people are in the same boat. We don't understand.
Yeah, I mean, I tried to do that a little bit at the start when you think about just the physics of what happens when you put more greenhouse gases in the atmosphere. And then we're putting more greenhouse gases in the atmosphere, and the CO2 concentration's going up, we can see that, and the temperature's going up. And you know, you can talk about the facts like that, and I've talked to a number of different groups, and sometimes what I find that people connect with is anecdotes, and as scientists, you don't like to tell anecdotes because there's always another anecdote from the other side. There's always that guy who's 92 and smoked all his life and then got hit by a bus and died. You know, there's always another anecdote for the other side, and that's what politicians always use. But sometimes those are the things that people identify with. If people can't understand, you know, that those arguments and the quite basic science which explains what's happening, it's a real challenge, and then people can get away with just about anything.
Thank you so much, Alistair.